Welcome back students in chapter number 12, video number 54. As you know, we are going to calculate that exercise examples. Let us see one of the finest examples of this chapter. Let us see. We are taking now, which term came? 12.6 or 12.7? 12.7. Let us say it is 12.7. This question may be of 3 marks, or if your luck will work, it can be asked as a 4-mark question. Okay, let us see. What is given? By using Bohr's model, calculate the speed, means velocity you have to calculate. Calculate the speed of an electron in a hydrogen atom in n is equal to 1, 2 and 3 levels. Means n value 1, n value 2, n value 3 you have to put. For what? To find the velocity. Okay? Then we will discuss that section number B. Okay? So, first of all, what is given? Nothing is given. N is equal to 1, 2 and 3 are given, but we have to find the velocity. So, for that, which are the equations in which we come? Okay? So, we will have first equation, that is mv square by r is equal to centripetal force is equal to Coulombian repulsive force acting between two charges. If it is hydrogen atom having charge, nucleus having charge Ze, Z value 1, so it is E. Charge of electron, again E, so it is E square upon 4 pi epsilon 0 multiplied by R square. This equation we have seen in simple method to find the equation of radius of hydrogen atom. Okay, so here R will cancel out, right? Take R on this side, so we are getting m v r. V square split V square into V multiplied by V. So take R on this side, that is mvr, what we remain, it is here, is equal to E square upon 4 pi epsilon 0. Is it okay? No. Here it will be like this, V square, but take V square like this. Why? Because what is mvr? mvr is nothing but Bohr hypothesis number 2. So mvr is nothing but nh upon 2 pi multiplied by this v, as it is equal to E square upon 4 pi epsilon 0. Pi will cancel out, 2 2s are 4. So we are getting nh multiplied by v is equal to E square upon 2 epsilon 0. What to find? V. So we will have equation v is equal to 1 upon n multiplied by, take h here, so we are getting E square constant value upon 2 epsilon 0, again constant value multiplied by h. So this is the standard equation to find the velocity. So let us see. For n is equal to 1, we are getting velocity for n is equal to 1 is equal to 1 upon 1 multiplied by E square, that is 1.6 multiplied by 10 raised to minus 19 whole square divided by 2 multiplied by epsilon 0 8.85 multiplied by 10 raised to minus 12 multiplied by h. What is h? Planck constant, that is 6.625 multiplied by 10 raised to minus 34. Do the calculation. 1.6 square, it is nothing but 2.56 multiplied by 10 raised to 19 to the minus 38 plus minus 12 minus 34, it is minus 46, take it upside, so it will be plus 46 divided by 2 multiplied by 8.85 multiplied by 6.625. Do the calculation in your calculator. Already I have calculated, okay? So we are getting final answer is 0. Divided by 2 multiplied by 8.85 multiplied by 6.25. So we got the answer, not we, I got the answer is 0.0218 multiplied by 10 raised to how much? That is 8. 46 minus 38, that is 8. Take 2 point here, so you are having 2.18 multiplied by 10 raised to 8. As it is velocity, it is meter per second. So this is velocity number 1. If you want to find for n is equal to 2, so put 2 here. All these things are constant. So to avoid the calculation, to avoid the excess calculation, there is one more method. Which method? Let us see. Here, keep n as it is. So is equal to 1 upon n will remain, is equal to, keep it as it is. So finally you are getting equation of velocity like this. Okay, if you want to find for n is equal to 1, so put n is equal to 1 here. So n is equal to 1. For that, v1 is equal to 2.18 divided by 1, so it is 2.18 multiplied by 10 raised to 8 meter per second. If you want to find for n is equal to 2, so you will get v2 is equal to, put 2 here, so that is 2.18 divided by 2 multiplied by 10 raised to 8 meter per second. So it will be 1.09 multiplied by 10 raised to 8 meter per second. Similarly, for n is equal to 3, v3 is equal to 2.18 multiplied by 10 raised to 8 divided by 3. So it will be, find the value by using calculation. See, very nice thing. Okay, by using this equation, find out v is equal to 1 upon n. Keep 1 upon n as it is. Then find the constant value, that is square upon 2 epsilon 0 h. So this is the constant value, 1 upon n as it is. Now here you have to make a change. Which change? What is asked? That change you have to make. So put n is equal to 1, so you will get v1. N is equal to 2, you will get v2. 3, v3. Okay, do this simple calculation, find the answer. It will be again in meter per second. Have a look. Then after we will see second part of this numerical. Let us see. Now what to find? Second part, that is calculate the orbital period in each of these levels. Means you have to find capital T periodic time for n is equal to 1, 2 and 3. Okay, let us see how to find. Same numerical, but second part, that means we have to find the orbital period of time, that is T. So how to find that T? We have equation. Which equation? That is velocity is equal to distance traveled by an electron during one orbit, that is 2 pi r divided by T. As you know, there are n, so Rn, Tn, Vn. So Tn is equal to 2 pi Rn upon Vn. So give it equation number 1. Clear? So find out the value of T number 1. Okay, so we will get, for n is equal to 1, you will get T1 is equal to 2 pi 2 multiplied by 3.14 multiplied by r. What is r? See the textbook, it is not given in our question, but for n is equal to 1, you have to keep in mind the value of r, that is 0.53 multiplied by 10 raised to minus 10 meter. 0.53 multiplied by 10 raised to minus 10 meter divided by V1, that is velocity number 1 that we have seen in first part. What was it? I think so. It is 2.18 multiplied by 10 raised to 6. Okay. Take it up. Do the calculation. 2 multiplied by 3.14 multiplied by 0.53 divided by 2.18. You will get 1.52 multiplied by 10 raised to minus 10 plus 6. Upside minus 6. It is minus 16 second. Clear? So this is the first value of period time for n is equal to 1. Now in this equation we know that what is Rn? Rn is equal to R1 by, sorry, not this, it is n multiplied by R1 and Vn is nothing but V1 divided by n. Check it out, it is n square multiplied by R1. So put these two value in equation number 1. So you will get Tn is equal to 2 pi as it is multiplied by n square R1 divided by V1 by n. So n will go up. So you will get n cube as it is 2 pi R1 divided by V1, whose value, this value we have already obtained here. See, it is here. So you will get the value of n here. So we have only one standard equation, that is Tn is equal to n cube as it is. The constant value having value 1.52 multiplied by 10 raised to minus 16 second. So in this equation put n is equal to 2. So we are having second value, that is 2 cube multiplied by 1.52 multiplied by 10 raised to minus 16 is equal to 2 to the 4 to the 8. 8 multiplied by 150, sorry, 8 multiplied by 1.52 multiplied by 10 raised to minus 16 is equal to, you will get the value, that is 12.16 multiplied by 10 raised to minus 16. Its standard format, that is 1.216 multiplied by 10 raised to minus 15 second. Similarly, in this equation, put n is equal to 3. Find the value T3 by your own. Have a look. Okay? These things are important. And rest of the things are very easy. Now, let us see 12.8. Again, important thing, analysis of this question. The radius of innermost electron orbit, innermost mean n is equal to 1, and that radius is given r1, okay, is equal to, how much given? 5.3 multiplied by 10 raised to 5.3 multiplied by 10 raised to, how much? Minus 11 meter. So, this value we have taken in our previous numerical, 0.53 multiplied by 10 raised to minus 10 meter. Okay? Now, what to find? What are the radii of n is equal to 2 and n is equal to 3 orbits? Oh, it is very easy. N is equal to 2. We have seen in previous numerical, that is Rn is equal to n square R1. So this is the standard equation for n is equal to 2. So you will get R2 is equal to, here, 2 square multiplied by R1, value is here, 5.3 multiplied by 10 raised to minus 11. So 2 to the 4 multiplied by 5.3, simple calculation, you will get 20.2, 20.6, yes, multiplied by 10 raised to minus 11, take 1 point here, so you will get 2.06 multiplied by 10 raised to minus 10 meter. Same way, n is equal to 3. So it is very easy now, we will do by our own. So it is 3 square multiplied by 5.3 multiplied by 10 raised to minus 11. Can you do it? Okay. Then you will get the value 4.77 is equal to 4.77 multiplied by 10 raised to minus 10 meter. Simple. Have a look. Only one equation. Maybe asked as a 2-mark question. Have a look. So this type of numericals are very easy if it is asked in our exam. Okay. Now let us see last but not the least, 12.9. Okay. What is given? Do the analysis. So we will have a 12.5 electron volt electron beam is used to bombard gaseous hydrogen at room temperature. See, this data is useful in that this data we have seen in that energy level diagram. Have you seen that energy level diagram? So it was like this. See, that means this is ground state, n is equal to 1 in this state, minus 13.6 electron volt was energy. It is n is equal to 2 first excited state, and there was a value minus how much? Minus 13.6 divided by n square, that is 2 square. Find out. Here n is equal to 3. Here the value is 13.6 divided by 4. So it will be 3.4 electron volt, and here minus 1.51. Okay, so 12.5 electron volt, it is the energy difference. Means electron may transit from n is equal to 2 to n is equal to 1. Electron may also transit from n is equal to 3 to n is equal to 1, or electron also can transit from 3 to 2. Okay, so this is the meaning. If there is 12.5, then electron may transit from n is equal to 4 to 1, 2, 3. It is not possible. Why? Because that gap exceeds. Okay, this thing we will see later on. Okay, now what is asked? What series of wavelength will be emitted? You have to find the wavelength, right? So lambda is equal to, આપણી પાસે equation હતું, right? Lambda is equal to, what was the equation? E is equal to HF, F is equal to C by lambda, and from here lambda is equal to HC by E. But here there are energy differences, so you have to find delta E. So this is our standard equation. Got it? From where this equation comes? Again, chapter number 11. Then we will see. Don't worry. Okay? Now, let us take first transition from n is equal to 2 to n is equal to 1. So, electron transit from n is equal to 2 to n is equal to 1. So this is the first possibility. First, same equation, that is lambda transition from 2 to 1 is equal to HC upon delta E, that is delta E to 1 is equal to, let us see first, what is delta E to 1? That is E2 minus E1 is equal to minus 3.4 minus 13.6 is equal to 10.2 electron volt. That electron volt you have to convert into joule. Put the value of HC. So value of H 6.625 multiplied by 10 raised to minus 34 multiplied by C 3 multiplied by 10 raised to 8 divided by delta E to 1. It is here, that is 10.2 multiplied by E 1.6 multiplied by 10 raised to minus 19. So we have converted into joule. Do the calculation. We will get, what we will get, 10.8 10.875, this multiplied by this, it is 10.875 multiplied by 10 raised to minus 26 divided by this two. So it will be 16.32 multiplied by 10 raised to minus 19. Take this up. Minus 26 plus 19, so it is minus 7. 10.875 divided by 16.32, we will get 1.21 is equal to 1.21 multiplied by 10 raised to 7 nanometer. Sir, it will be 7? No, minus 7. Okay, minus 7 not nanometer, it is in meter. Take 2 point here, so we are getting 121 multiplied by 10 raised to minus 9 meter, and 10 raised to minus 9 meter is nothing but nanometer. Okay, so this is at that point when electron may transit from n is equal to 2 to n is equal to 1. Clear? Now, in this equation, in this we will take modification. We will do some modification. If electron may transit from n is equal to 3, then here 3 1, 3 1. So here n is equal to 3. What is the value? That is 1.51. So it is 1.51. So 13.6 minus 1.51, we will get 12.09. 12.09 electron volt. So just we have to make here one change, that is 12.09. So it becomes what? 19.344. 19.344. So 10.875 divided by this, do the calculation, you will get 1.027. 1.027. Take 2 point here, so we are getting 102.7, and here we will get 102 nanometer. It is very easy. Okay, similarly do it. That is lambda 32 is equal to same equation, Hc upon delta E 32. What is delta E 32? Is equal to E3 minus E2. Values are here, E3 minus E2. So there will be a change in this value only. Find out the answer. Write in a proper manner in our notebook. Send the PDF in our homework group. Okay? Have a look. Good luck. Thank you.